Hello and welcome to another WJEC A level physics question. This time it's question 7 from the June 2013 Unit 4 paper, and it's a question basically on electrical fields and electrical forces with a bit of gravitational work in there as well. Nowadays you will find those topics still in Unit 4. So what we've got in this question is we've got two spherical balloons. They've got a mass of little m each, and they're carrying a certain number of excess electrons distributed over their surfaces, and the total excess charge on each balloon is minus 2.55 times 10 to the minus 7 coulombs. Now the balloons then are hung from the same point by light strings, so we can ignore the mass of the strings, and these strings have got a length of 0.75 meters, and each string makes an angle of 10 degrees with the vertical. The weight of the balloons is mg, and there are electrostatic forces shown on the diagram as well, and also the tension in the strings. We're going to use information in the diagram to show that the separation R of the centres of the balloons is approximately 0.26 meters. If you want to be a bit of a show-off here, you could use sine rule, because we've got that this side is 0.75 meters, and if this is a 10-degree angle up here, this is an 80-degree angle. So let's do it that way. Most people would have done it by just sort of breaking it down into finding the distance between here and here, where that would be half of r. But if we use the sine rule, then what we've got is that 0.75 over sine of 80 is going to be equal to r over sine 20. So r is 0.75 times sine 20 all over sine 80. Just make sure that your calculator is not in radians mode if you've been doing any work on simple harmonic motion, for example. If we put those numbers into the calculator, we end up with 0.260. Okay, pen doesn't want to write. Let's try that again. Oh, there we go. Just a bit of a delay. Okay, calculate the electrostatic force on each balloon. Well, what we've got here is we're going to have to look at the forces acting between the two balloons. The force between two known charges is given by Coulomb's law, where we have F equals 1 over 4 pi epsilon naught Q1 Q2 over R squared. So 1 over 4 pi epsilon naught we can take as 9 times 10 to the 9. Both balloons have the same charge of 2.55 times 10 to the minus 7. We can ignore the minus sign if we like. We're simply going to get repulsive forces here because the charges are the same. It's at minus 7, I believe. Yeah. And because both of the balloons have got the same charge, then when we do Q1 times Q2, we're going to get Q squared. Now, what I've seen here as a mistake every now and again is that people think that Q1 times Q2 is 2Q1 when the charges are the same, but instead it's Q1 squared. And the R is the 0.26 meters that we've just calculated in the previous part of the question. So let's put that data into a calculator. And we end up with 8.63 times 10 to the minus 3 newtons. Next we have to show that the electrostatic potential energy of the system is 2.25 times 10 to the minus 3 joules. Formula for this is in the data book. The potential energy is 1 over 4 pi epsilon naught Q1 Q2 over R. So 9 times 10 to the 9 times 2.55 times 10 to the minus 7 squared again over the 0.26. Now, a quick way of doing this on the calculator is to realise that the only difference between this calculation and the previous calculation is we have R on the bottom instead of R squared. So if you multiply your last answer by 0.26, you will find that you get 2.247 times 10 to the minus 3 joules. So just a little bit of a time saver. Next, we're going to use the answer to A2 to show that the tension in each string is 0.05 newtons. So let's look at, for example, this right-hand balloon. Here, this horizontal component of the force that I've labelled here will either be F cos 80 or F sine 10, T sine 10. And because the balloon is in equilibrium, we know that T sine 10 and F must balance each other. There must be no resultant force in any direction. So the idea is that the sum of the forces to the left equals the sum of the forces to the right. So T sine 10 is equal to the 8.63 times 10 to the minus 3 newtons for the electrostatic force. So T is 8.63 times 10 to the minus 3 over sine 10. And that actually gives us 0.0497 newtons, so near enough the 0.05 newtons that we're asked for. To find the mass of the balloons, this time we're going to resolve vertically and say that the sum of the upward forces equals the sum of the downward forces. Upwards we'll have T cos 10, downwards we have the weight. So here the mass will be T cos 10 divided by G, or 0.0497 times cos 10 over 9.81, and that gives us 4.99 times 10 to the minus 3, near enough 5 times 10 to the minus 3, and it's a mass, so it's kilograms. Thank you very much for listening. Please remember to like and subscribe, and feel free to ask any questions. Goodbye now.